In any scientific field, from time to time, an especially relevant discovery is made, allowing considerable advances in the knowledge and possibilities. In a disruptive way, HEATSENS technology is one of these discoveries in the field of biosensors. The development of advanced biosensors could affect positively our lives. The detection of biomolecules, bacteria and other elements that allow us, for example, to know whether food meets all the necessary conditions for consumption, or to detect contaminants in water. It is so important that in 2012 they reached a market of $8.5 billion and that all market studies show that it will double in 2018. But there is still a long way to go in this field. Perfect biosensor should have a very high sensitivity in order to detect analytes present in low quantities and should be very specific, recognizing only what we want. And not less important is the simplicity of its use without requiring a pre-treatment of the sample, giving the result in a low time and be sufficiently portable and simple that anyone could use it anywhere. However, in many applications, biosensors available on the market are still not sufficiently sensitive, simple, portable, or without offering the result in a reasonable time. But why is that so important that biosensors have such properties? For example, with a more sensitive biosensor, we could detect diseases such as cancer in the early stages, increasing the patient life expectation. But how could we reach a highly competitive biosensor? Let's see what a biosensor is. A biosensor is composed of several parts. On one hand, there is a biological element known as a receptor, able to recognize a selective analyte of interest. This part defines how specific the biosensor is. This receptor is linked to a transducer element, commonly known as a label, which is in charge of converting this biological recognition interaction into a type of signal that we are able to observe and measure. For example, an electrical charge, a magnetic field, or a colour change. This part defines how sensitive the biosensor is. Finally, we have the display, consisting of the elements in charge of adapting and showing such signal so that the operator can interpret it. Consequently, it seems obvious that if we want to improve the sensitivity of a biosensor, the label that is in charge of the transduction process is important. But what is being done today in that field? In the field of immunoassays, biochemical tests that use antibodies as biological receptors, the direct recognition was initially used, but not sensitive enough. The immunoassays have therefore improved in terms of sensitivity, with the introduction of the ELISA technique that uses enzymes as labels and the immuno-PCR that uses DNA chains instead of enzymes.